Hello friends, now we are studying percentage bias differential protection. So what is percentage bias differential protection means? So guys, you will see what is the difference between here is we put one coil in restraining part. Restraining coil, we put one coil instead of the spring. So in this branch, what current will flow? I1 minus I2, and the turn ratio is N naught, and this the current will be I1 in this direction and I2 will be in this direction. So I2 will be in this direction. So we know that if I1 in this direction, so total current will flow, that is I1 minus I2. If the current here is I1 and here is it is I2. So simply you can see from here. So now we will use the principle of MMF. So relay will operate when MMF of relay will operate when MMF of operating coil will be greater than MMF of restraining coil, because we know that torque will be derived from MMF, flux basically MMF. So we can see from here that N naught into I1 minus I2 must be greater than NR. So basically see guys, is NR, this is divided between two parts. Half part I1 is flowing, here it is I1 flowing, and half part is I2 flowing. And the basic thing is the current is in the same direction if you look carefully. So we can say NR by 2 into I1 plus NR by 2 into I2. So this is the condition relay to be operate. So we can say N naught I1 minus I2 must be greater than NR into I1 plus I2 by 2 basically. So what we can see from here that if relay 1 has to be operated, then I1 minus I2 must be greater than NR upon N naught I1 plus I2 by 2. So this is the condition. So wedge of condition will be what? Wedge of condition will be at wedge of condition at wedge of means verge condition. At wedge of condition we can see that I1 minus I2 will be equal to NR by N naught I1 plus I2 by 2. So simply what we can see here that the relay will operate when I1 minus I2 greater than NR upon N naught I1 plus I2 by 2. We can understand this concept by taking this y is equal to mx. Let us assume this is y is equal to this is m into x. So if we will draw the relation between I1 minus I2 and I1 plus I2 by 2, then we can see easily here that if this is I1 minus I2 and this is I1 plus I2 by 2, so simply we can see here that this straight line passing from origin, this will be our m. M is equal to slope, and that is NR upon N naught. So what basically you can see from here that relay will operate when this I1 minus I2 must be greater than NR upon N naught I1 plus I2 by 2. So this is very good point that in mathematics you have been studied that this is the particular reason in which I1 minus I2 will be greater than your NR upon N naught I1 plus I2 by 2. This is the condition here, and this condition, this I1 minus I2 will be less than NR upon N naught I1 plus I2 by 2. So basically what we got from here that this will be the basic operating point, operating zone. So we can change this operating zone by changing the value of this slope. You can see clearly we can change this operating zone by changing this NR upon N naught, means we can give the bias, according to ourselves. We can give the bias according to ourselves, so that according to ourselves we can operate if any kind of fault happens. So this NR upon N naught used to be biased, so that is why this relay is also called as percentage bias differential protection. So this time is this time it is not necessary that if the difference will be not zero, then the relay will operate or not. So we are going to see with the help of few numerical. So we have this situation: if the fault occur having a heavier value of impedance, so 110 ampere will be here if 100 ampere is here. So you can see, and percentage bias is equal to given, percentage bias is equal to given as 10%. So we have been asked whether this relay will operate or not. So we will check. From here this current will be 5.5 ampere. What it looks like, there is a difference in current. So it should have been like the relay will simply operate, but we have to check now. The both the current in secondary are different. It's 5.5 ampere and here it is 5 ampere. So we will see that relay will operate when I1 minus I2 would be greater than NR upon N naught, mean percentage bias I1 plus I2 by 2. So we need to calculate this value. So I1 minus I2 will be equal to 5.5 minus 5, that is equal to 0.5. And I1 plus I2 by 2 will be what? I1 plus I2 by 2 means 5 plus 5.5 by 2 means it will be equal to 5.25. So this is I1 plus I2 by 2, and we have to multiply it by this percentage bias. So NR upon N naught total I1 plus I2 by 2 will be equal to 0.1 to 0.525. That is coming out to be 0.525. So this is the restraining quality. So this is the restraining MMF. This is the restraining MMF of restraining coil, and that is greater than the difference between this I1 minus I2. So when restraining is greater than operating, so the relay will not operate. So this condition, although we have different current, but the relay is not operating. But when we will change from 1 to 120, and this time we will calculate, this time relay will operate. I have done this thing and you can also check, so it will be easy for you to understand in a better way. So this is all about percentage bias differential protection.